Okay, so now we're going to go ahead and do our lecture over Chapter 5, Collecting Quantitative Data from your Creswell text. So let's go ahead and dive into this, shall we? So, the process of collecting quantitative data consists of more than merely collecting data. You have to decide who your participants will be, then you'll have to get their permission to do so. You have to figure out what type of measures will be appropriate for the type of data you're going to collect that will properly answer your research questions and locate instruments to use. And then you can start collecting data at that point. There are 5 basic steps in the process of collecting quantitative data. The steps can be asked by these 5 questions. Number 1, what participants will you study? Number 2, what permissions will you need? Number 3, what are your options for collecting information? Number 4, what instrument will you use to collect data? And finally, how will you administer the data collection? So, step 1 in collecting quantitative data is that you're going to need to identify your participants. So, let's go over that. First, you're going to need to identify your unit of analysis. Think, who can give you information to answer your research questions or hypothesis? Such participants can be students, teachers, parents, adults, or a combination of these, or even entire schools. Doing this determines what level you're going to be gathering information from. For example, individuals versus schools. This is called the unit of analysis. Also, the unit of analysis may be different for the independent variable and the dependent variable. Next, you must specify the population and sample. If you're going to study an entire school or just individuals, you must choose which school or individuals you're going to study. An advanced method is to choose individuals or schools who represent the entire group of individuals or schools. This is called representative, which means you select individuals from a sample population that represent the typical population being studied. This enables you to make conclusions from the sample and apply it to the population as a whole. So, think a population is a group of individuals who have the same characteristic. For example, teachers or administrators. A target population, also known as a sampling frame, is a group of individuals or a group of organizations that have a common characteristic that the researcher can identify and study. A sample is a subgroup of the target population that the researcher will study to make generalizations about the target population. So, here, when you're identifying your participants, here's a kind of a visual of what that looks like. On the left, it's the target population, and this may be all high school teachers in one city. And the sample, let's say that could be high school teachers, say from an overall population. So this is the most rigorous form of sampling, and it's called probability sampling. And then on the right, you may only be able to study biology teachers in 2 schools of a city. This is called non-probability sampling. So, moving forward, probability sampling is the most rigorous form of sampling in quantitative research because you can claim that the sample represents the population as a whole, and then you can make generalizations to the population. This is when you select participants from the population that represent the population. Then you move on and we have non-probability sampling. The researcher will select participants that are easily available and convenient, but do represent some type of characteristic they seek to study. Generalizations are not usually made to the population as a whole, but only to a small group of participants within the study. So this flowchart shows quantitative sampling strategies, and they're divided as probability sampling and non-probability sampling. Probability sampling is further divided into 3 strategies. You have simple random sampling, stratified sampling, and multi-stage cluster sampling. Then you have your non-probability sampling, and that's further divided into two strategies: convenience sampling and snowball sampling. And we're going to look at all of these. So there's different probability sampling techniques. So let's look at those first, just your probability sampling techniques. Remember, these are going to be more rigorous. So it says simple random. This is the most popular and most rigorous form of sampling. The researcher selects participants for the sample, and they all have equal probability of being chosen from the population. You would assign each person in your sample a number, and then use a program such as SPSS, and that's what I use for mine, and to randomly select your participants. That way, any bias is equally distributed across the population. Then you have systematic sampling. This is a slight variation of your simple random sampling we just discussed. In this procedure, you would choose the nth individual until you reach your desired sample size. So, like maybe the seventh person, and you just keep going 7, 14, 21, and go on. And then you would just get every seventh person, and that would be your sample size. Okay. And then there's another one as far as probability sampling approaches, and it's stratified sampling. Researchers divide or stratify the population based upon some characteristic like gender, and then uses simple random sampling, which is what we just discussed prior to the nth one, which was your systematic sampling. And it's the most popular and rigorous method. Then samples from each subgroup, say male and female of the population, are called the strata. You would use this when there is an imbalance on a characteristic of a sample, such as more males than females in your population. To do this, you would first divide your population by the characteristics studied, which is your stratum, like male and female. Then sample within each group of the stratum, male first, then female, so they are proportional to the representation of the total population. Next, we have multi-stage cluster sampling. This is when the researcher chooses a sample in two or more stages because the population can't be identified or is just really big. An example being at-risk students in the U.S. So you would identify at-risk students at select school districts. So then you would randomly select school districts in the U.S. and then obtain lists of those at-risk students from each of those school districts. Then you would randomly sample within each district. So it just kind of has to be done in multi-stages, hence the name. Here we have a chart. And so we're still looking at identifying participants in your study. So if you have stratification, like we discussed earlier, um, this is a proportional study. So the boys sampled represent the total population, and the same for the girls. So let's look at the Venn diagram. The Venn shows that the large circle labeled N equals 9,000. So that's your total population. And within that, there's boys of 6,000 and girls of 3,000. Well, then they went ahead and stratified and took a sample from each of those groups to represent the overall population. And so girls represented about a third, and so they got 100 sample in their sample, and then boys represented about 2/3, and then so they got 200. So your sample size would be 300, and so they both represent a third and 2/3 respectively. Okay, so now we're going to go ahead and we're going to talk about non-probability sampling approaches, and that's what it should say right here is non-probability sampling approaches. So I apologize for that typo. But the first one is the convenience sampling. The researcher selects participants because they are willing and available to be studied. With this, you cannot say that the sample represents the population, okay? But next, you have snowball sampling. And this is when the researcher asks participants to identify others who could be part of the sample. Those in the study may not represent the population either, okay? It is important to determine the size of your sample. Generally, it's good to select the largest sample possible for your study because it will yield less room for error that the sample will be different than that population. You have sampling error, which is the difference between the sample estimate and the actual population score. And then you have sample size formulas, and they're used to provide a way to calculate your sample size based on multiple factors. Using a formula takes the guesswork out of figuring out the number of participants to study and give an accurate estimate of your sample size. Such factors used to calculate your sample size include the confidence in the statistical test and sampling error. Two formulas are used. Number one, sampling area error formula for surveys, or you'll see that they use what's called a power analysis formula for experiments. Now we're going to talk about step two in collecting quantitative data, and this is obtaining permission. So once you've identified and selected your participants of your study, now you need to get the permission so that to study them. This permission will include an overview of your study, their expected participation, and the procedures of the study. Now, federal legislation requires you guarantee them certain rights that you request their permission to be involved in your study. For most educational research, you need to get permission from several individuals and groups before you can begin gathering data. Such places could include the places that are on the slide, and I'll let you read those. So the best way to get permission is to formally in an email or a letter, okay? So include the purpose of the study, the time that you're going to be collecting the data, how long they're going to have to participate for your participants, and how you will use the data. And also state the activities that you're going to conduct and the benefits that they will get from the study and how you plan to protect their privacy and how that they'll remain private. Okay. So institutional review boards, or you'll hear me say an IRB. Okay, it's a committee made up of faculty members of at least one individual not affiliated with the institution who review and approve research so that the research protects the rights of the participants. So it's kind of like a checks and balance system. So the process of gaining permission and approval from the IRB varies from campus to campus. Here are some basic steps both student and faculty researchers complete when seeking approval. First, start by finding out about the review process used from the IRB on your campus. Next, determine what information the review board needs about your project. Then, develop an informed consent form for participants to sign before they participate in the study. And then finally, submit a description of your proposed study to the IRB. Once approved, you can proceed with the study. If denied, you will need to visit with the board representative to determine why it didn't get approved and what you need to do to change it to gain approval. Here's a flow diagram divided into two parts, one showing flow of activities and the other showing examples. The flow diagram is as follows. Identify the variable, and an example of that would be self-efficacy for learning from others. Then operationally define the variable, and then you can read the examples, and then locate the data, measures, observations, and documents with questions and scales with the example, and then collect data on the instruments yielding numeric scores. So now we're going to move forward. Now we're collecting information, okay? So this is step three in analyzing, collecting quantitative data. So you've gained permissions, you've chosen your participants, you've designed a procedure to get the permission, and then now you need to select forms of data that will help you in answering your research questions or address your hypothesis. You have to identify your variables in your questions and hypothesis. This will include your IV, your DV, and your control variables. An operational definition is the specification of how you will define and measure the variable in your study. You need to identify how you're going to measure your variable and cite other authors who have identified how to measure it. So that's important for you to cite other authors right there in your paper, okay? So still collecting information. An instrument is a tool for measuring, observing, or documenting quantitative data. In quantitative research, there are four major types to be collected. Number one, measures of individual performance, such as achievement tests, which are like norm reference tests, like the Iowa test, or criterion reference tests, like a GED, aptitude test, and more. Number two, measures of individual attitude. These are like affective scales. Number three, observation of individual behavior, like a behavioral checklist. Number four, factual information, and that could be like public documents or school records. And we're going to go into more detail of all of those. So, performance measures assess an individual's ability to perform on an achievement test, an intelligence test, aptitude test, interest inventory, or personality assessment inventory. And so, then here's an example of an instrument that measures performance. The test assesses aptitude, abstract reasoning, and problem solving. So we're going to collect some information. And so if you have attitudinal measures, this will assess attitudes or individuals. This is a popular form of quantitative data when you're doing surveys. Correlational studies and experiments. Researchers use these when they want to measure feelings towards educational topics. They should be written to encourage an unbiased response. A drawback is they do not provide direct evidence of specific behaviors, such as if a student actually can carry a weapon to school. Behavioral observations are made by selecting an instrument or protocol to record a specific behavior, observing the individual for the behavior, and checking points on a scale that reflect the behavior. Quantitative numeric data are also available in public educational records. This could be like your factual information or personal documents, which consist of numeric individual data available in public records. This could include like your grade reports, school attendance records, student demographic data, and census information. Currently, digital methods of data collection include the use of websites and the internet for administering surveys, gathering interview data, mining social media data, or using existing databases for analysis. So, to select your data sources, you're going to ask yourself three questions. What am I trying to learn about my participants from my research questions and hypothesis? What information can you realistically collect? And then, how do the advantages of the data collection compare with its disadvantages? Now we're going to move into the fourth step when you're collecting quantitative data. And the fourth step, you're going to choose what instrument. Okay, so when you collect your performance, attitudinal, or observational data, you're going to use an instrument to collect data. Three options exist when selecting an instrument to use. You can either create one yourself, locate one and modify it, or locate one and just use it as it is. Locating one and using it, or modifying it and using it as it is the easiest method because you don't have to go and create your own. But modifying an instrument means locating an existing instrument, obtaining permission to change it. You can't just go and change it on your own. And then making the changes to fit your requirements. If there's not an instrument to measure the variables in your study, then you'll have to create your own instrument, which is not an easy task. There are four phases in development, and those phases are right here: planning, construction, quantitative evaluation, and validation, which means checking to see if the questions work. Okay. If you decide to use an existing instrument, the author, whoever created it, they could charge you a fee to use it. And when you're looking for an instrument, there's strategies that you can use to find one. You can look in published journal articles. You might find one that way when you're doing like your literature review. You can run an ERIC search, or you can examine guides to test and instruments that are available commercially. Okay. Once you find your instrument, several criteria can be used to assess whether it's a good one to use. Okay, so ask yourself these questions. Have authors developed the instrument recently? Is it widely cited by other authors? Are reviews available? Is there information about the reliability and validity on it? Does it fit the research questions in your study or your hypothesis? Does it contain accepted scales of measurement? You want to choose an instrument that reports individual scores that are reliable and valid. So let's talk about reliability. That means that the scores from the instrument are stable and consistent. Scores are nearly the same when administered multiple times at different times. So here are different types of reliability. Next is validity. It is the development of sound evidence to demonstrate that the test interpretation matches its proposed use. So that means it just tests what it's intending to test, okay? And so here I want you to look at the different forms of validity, okay? After reviewing the forms of reliability and validity, let's look at the questions you should ask when selecting or evaluating an instrument. Here's a short list of questions that you can ask yourself. It's important that your instrument also contains the record keeping process that fits the data you need to answer your research questions or hypothesis. Who is going to record the data? It may be self reported, or the researcher may record the data. When participants record the data, that saves time, but the researcher, when they record the data, they'll become familiar with how the participants responded, and then they can control for a higher level of quality of the data. So keep that in mind. Another requirement is that the instrument should have good response options to the questions. There are two basic types of scales of measurement: categorical and continuous scales. Categorical scales have two types: nominal and ordinal. Continuous scales have two types: interval, quasi interval, and ratio scales. So here are your categorical types. You've got nominal scales, and they provide response options where the participants check one or more categories that describe their traits, attributes, or characteristics. And also another categorical type is an ordinal scale, and that's ranking scales. They provide a response where participants rank from the best to worst, okay? Then we move on to our continuous scales. And so that's your interval and ratio scales. Those are both continuous, and they provide continuous response options to questions with assumed equal distance between options, like a Likert scale, like I strongly agree to I strongly disagree. Okay. Now, a combined scale is they use more than one scale. Using Okay, so now we're going to move into the last step of when you're collecting your data, okay? And that's going to actually be collecting your data. So you use a standard process, and you also need to make sure that you follow ethical practices when you're doing this. Standardization is essential to eliminate bias and to keep you on track. So it also helps you analyze your data properly. You don't want to do something and do it wrong, and then follow a standard process. And then data collection should be ethical and then respect individuals and sites. And then you can look at the parent involvement study to see the data collection procedures, okay? So that is collecting quantitative data in a nutshell. If y'all have any questions, let me know and I'll be glad to help you. Take care.